Hello everyone. Another example in this context-free grammar. So given a grammar, so what you're going to do now, like list all the terminals and non-terminals in the given grammar, and you're going to check whether the string can be derived or not. And we have to simplify the grammar, convert the grammar into Chomsky normal form structure. Okay, so coming to this place, so this is the grammar that you're going to consider, and what is the like whenever it is in grammar, what are all the elements of a grammar? Any context-free grammar will have set of variables, terminals, a starting symbol, and a production rule, and set of production rule. Okay, variable are also called as non-terminals. Okay, so these are all the one that comes in this side. Okay, so anything that comes in this left-hand side that has a production for itself. This is called a variable or non-terminal. Okay, so now when you want to list all non-terminals, what all there in this list? Your variables or non-terminals are, you have S here, NP and norm, VP. See, S, NP, norm, VP, and you have DET, noun, DET, noun, verb, and AUX. So these are all the set of variables, or we also call that as non-terminals. Okay, so non-terminals or a variable or something that comes in this left-hand side and that has a production for itself. And what will be the terminals then? Terminals you have to check in the body of production. Okay, so in this place, other than this non-terminal, like not NP, AUX, all these things have a production for itself. So all these things are a variable. And here you have this, that, this, the, book, flight, meal, man, book, include, read, does. So all these things are terminal symbols. Okay, so terminal symbols are the one that comes in your input. See, when I want to derive the string, the flight includes meal and the man reads a book. So this is called this single element, right? These are all your terminal symbols. Okay, so terminal symbols are the one that comes in your inputs. So when you have to check in the body of the production, other than your variables, other than your non-terminals, what all the left out thing is there, that will come in this terminal. So here you have that, this, the, all those things. You have to write all. Okay, so all this, and this are your non-terminal or all your terminal symbols. Okay, so you have to write all those things. So first, are you clear with it? Like what are all the list of terminals and non-terminals? Good. The next one is we have to check whether the above grammar could generate the string. The flight includes meal and the man reads a book. So whenever you want to generate a string, the first step is to check whether all the terminal symbols are available in the given grammar. For example, the first element is the. You check, is there any possibility of having the? It is there. Flight, flight is also there. Include is also there. Meal is also there. And see, nowhere in the given grammar you are able to derive this and. Okay, so when you're not able to derive one element in your input, then it is not generating. We cannot able to generate the string using this grammar, right? So this terminal symbol is nowhere found in the given grammar. So we can directly write it like you have to mention all the steps and you can write that this and is not possible to derive using this grammar since none of the terminal symbol derives to this variable, this terminal as and. Okay, so with that you can stop. So for this example, we can say that this string is not able to, we are not able to generate the string for the given grammar. If you are able to derive, if all the strings are present, then you have to start from the starting symbol, make some substitution and derive the parse tree generating this input. Okay, you have to verify all possible combinations. Pakka? The last one is we have to simplify the grammar and convert the grammar into a convert the grammar of context-free grammar to Chomsky normal form format. Okay, so first step is simplification of the grammar. So when it comes to simplification, what are the steps that we have in simplification? We have three steps, right? First is removal of all your useless symbols. Next step is elimination of epsilon production, and next is unit production. So you have to verify all those cases whether it is possible or not. And when it comes to useless symbol, we have two types of useless symbol. One is non-generating, another one is not reachable. Okay, so when we can call something as non-generating here, whenever you are drawing a pass tree, when the variable comes into your pass tree, it should stop somewhere and derives to set of terminal symbol. For example, I'll start from this place like det, noun or verb or acts. So when I have this aux in my parse tree, I can make a substitution for this aux as does. Okay, so with that it stops. The parse tree will stop. We don't have any other derivation for it. So this variable derives to a terminal symbol. So we can call this variable as a generating symbol. Okay, a generating symbol, all your reachable symbols, or we have to focus only on the variables, all these symbols. Okay, not the terminal symbol. Now, when AUX comes, we can make a substitution as does. When a verb comes, we can make a substitution as either book or include or read. That from with that, your pass tree will stop. So this is also generating, noun is also generating, det is also generating. Okay, so this actually means that when these variable comes into your pass tree, we can stop the pass tree by making a substitution of either when det is there, we can make a substitution of that, your pass tree will freeze at the place. No more extra things are needed. Okay, so now we'll check for this VP. So VP has two production. You can take any one. I'll take VP tends to verb. And for this verb, we have a lot of substitutions, right? I can substitute it as either book or include or read. Okay, if I made the substitution as read, then my pass tree stops. Okay, so I don't want to make any more substitution here. So we can call this VP is generating. Okay, either it derives to a single terminal symbol or it derives to some set of terminal symbol. So we can call this VP is also generating. And you have norm. When you have norm, norm can be substituted with noun. Any one possibility here. And noun can be substituted with anything. If I make the substitution as man, it is also generating. Okay, so noun can be substituted as noun can be substituted as man, and that the pass tree stops. Okay, so this is also generating. So your norm is also generating, and we have NP. For NP, we have only one production, right? That is det norm. For det, we can have the substitution as either this, that, a, or they. I can make any substitution. I make the substitution as a. And for norm, no, for norm, you have two possible productions to be substituted. I'll take the one production as noun. And for noun, you have a lot of substitution. If I make the substitution as man, then it stops, right? A man. For NP, you have only one possible productions, that is det and noun. And for det, when you make the substitution as a, this branch stops. And for norm as noun as man, this stops. So as a whole, when NP is there in the pass tree, it is able to generate to some set of terminal symbols. So we can call this NP is also generating. So this is how you have to verify here. And you have S. For S, you have three different production. Take any one. I'll take S tends to VP and VP tends to verb and verb tends to anything of this, book, include or read, anything. Okay, so this is also generating. From S, when you start the production, when you make all the substitution, the pass tree actually stops somewhere, right? So this is also generating. S is also generating. Okay, so with this, we can say that there is no non-generating symbol. Pakka? And next one is find all not reachable symbols. So reachable symbol are the one that starts from the, like whenever you are deriving some a string like this. Okay, so if some string that you want to derive from the for the given grammar, we have to start from the starting symbol. Okay, so from S, what all symbols are not called will be your non-generating symbol. Again, we are going to focus only on your variables. Okay, so from S, it is able to call NP, BP. Okay, so S is generating, sorry, S is reachable. From S, this NP, VP is called, and see here in this production, AUX is also called. And from NP, DET is called and norm is called. And from norm, noun is called. Okay, and from BP, verb is called. This BP is called and verb is called. Okay, so from the starting symbol, we are able to reach all the other variables. Okay, hence we can call that all the symbols are reachable. So there is no not reachable symbols. So as a whole, we can say that there is no useless symbol in the given grammar. So you have to write all the steps. Each step carries mark. Okay, so the next step is epsilon production. So in the body of production, you don't have any epsilon production. So there is no epsilon production. You can stop at this place too. Okay, and finally you have unit production. What is a unit production here? Whenever you have this structure of a variable tends to variable, like A tends to B. A single production, a variable tends to single variable. This is called a unit production. So you have to check all those places where you have unit production. You have this S is a variable, NP is a variable, VP is a variable. A variable tends to two variable is allowed. And here it is three variable, it is also allowed. See here, S tends to VP, a single variable, it is not allowed. So you have to take this production separately. S tends to VP is a unit production. And here you have two non-terminal. Norm tends to noun. Noun. So this is also a unit production. And you have two variable. VP tends to verb is a unit production and verb tends to. And here these you cannot call these as a unit production here. Since this is a variable and this is a terminal symbol. Okay, what we have to focus on is a variable tends to variable. So you have only in this category and these three are the unit production that you have to focus on. Okay, so we have to remove all this unit production. Now look at this here, BP tends to verb. So when you have how you eliminate your unit production here, instead of this verb, substitute the production for verb. That is how we eliminate unit production. So VP tends to, instead of verb, write the production for verb. That is book, include and read. When you write that, it is done. VP tends to book or include or read. Okay, remove this and include this production. Unit production is removed. And you have norm tends to noun. So instead of noun, substitute the production for noun. For noun, you have either book or flight or meal or man. Write all those things. Book or flight or meal or a man. So this production is also eliminated. For noun, you have only one production, right? Substitute that alone. It is fine. And finally, you have to eliminate this unit production as S tends to BP. So can you do that? You have this production S. And for BP, you have two different production. So you have to add both. So first production is S tends to, BP tends to verb that is already converted into this structure. See, for BP, you have this production and this production. Okay, so already unit production of this BP is removed. So I'm just going to substitute here as verb NP or these production like book, include, read. Okay, so when you've done this, so the simplification step is done. So finally you have to write as a whole here. I'll just show you how to complete this simplification step. You have to mention that there is no useless symbol, no not reachable, no not generating, not reachable. So no useless symbol and no epsilon production. And for unit production, we have 3 unit production. And after that, this is the these are all the elimination step. And finally, you have to show that this is the final grammar after eliminating your uh, what is this simplification step, unit production. So after simplification, this is your final grammar. Okay, see, the unit productions are removed. S tends to, and you have this verb BP tends to, and noun tends to, norm tends to. So you have removed all those things. Okay, so next step is to convert the grammar into Chomsky normal form, CNF, and the general format for CNF is a variable tends to two variable or a variable tends to a single terminal symbol. Okay, so we'll come from the back end so that a lot of things can be neglected directly. AUX tends to does. So does is a terminal symbol. A variable tends to terminal symbol is allowed. So this is in your general format. A verb tends to book is a terminal symbol. A verb tends to include is also a terminal symbol. A verb tends to read is also a terminal symbol. So this is also in the general format. Okay, so all these things are single terminal symbols. So the entire thing is in general formats. Here also BP tends to book, include or read. All single terminal symbols, which is allowed. And norm tends to a single terminal symbols, which is also allowed. And here also a variable tends to a terminal, all allowed. Okay, so these are all the grammars that are already there in the structure. A variable tends to a single terminal symbol. Now we'll start from the first. For S, you have the production as S tends to. S is a variable, NP is a variable, and BP is a variable. So S tends to, a variable tends to variable is allowed in your CNF structure. So this is allowed. Okay, and here S is a variable, AUX is a variable, NP is a variable, and BP is a variable. A variable tends to three variable is not allowed, so you have to rephrase it. Okay, so we'll come back, we'll complete the entire grammar, we'll take out what all to be rephrased and we'll just carry out with that alone. Okay, so here you have S tends to verb is a variable, NP is a variable. As a variable tends to two variable is allowed and a variable tends to single terminal symbols are also allowed. Okay, so this is in CNF structure. NP is a variable, DET is a variable, DOM is a variable. A variable tends to two variable is allowed. And here norm is a variable, noun is a variable, norm is a variable again. A variable tends to two variable, it is also allowed. Here BP, verb is a variable, NP is a variable. Two variable, it is allowed. So the entire grammar is in CNF structure except this. Okay, so what you have to do for it? You have the production as S tends to AUX, NP, VP. So one thing can be done is insert a new variable as X1 that takes this NP, VP and rewrite the production of S as S tends to AUX, X1. So here it is in variable tends to two variable and a variable tends to two variable. So you have splitted a single production into two productions. Okay, so this is your CNF structure. So finally, how you have to produce here, how you have to write it? S tends to NPVP, and instead of this production, you have to write the entire production, and instead of this S tends to AUX NPVP, you substitute this production. Okay, so with that, you can say that the given grammar is in CNF structure. So you don't have much things to be worked out here, but the thing is the way in which you understand. Okay, to know what is an useless symbol, what is an epsilon, what is an unit production, and how to proceed on it matters a lot. Okay. Okay, so this is the final CNF grammar. You have to write it here. So S tends to AUX X1 and X1 implies NPVP. Okay, so one more thing, if you are asked to convert the same grammar into Gribach normal form GNF, how to proceed with it? For any grammar to be converted to be a GNF structure, the grammar should be in CNF. And what is the general format here? A variable tends to a single terminal symbol followed by A1, A2 till AN. Okay, so usually we go with this renaming method. Okay, so it is a variable tends to a single terminal symbol followed by zero or more terminals. Like you can have A tends to A or A tends to A1, A2 or A tends to A1, A2, A3 or any number of elements. Okay, so this is your general format. So here usually what we do now, we take all your non-terminals, rename it and go ahead. But the problem is when you have plenty of this elements together, we cannot proceed on the structure. Okay, so what can be done in this place is first we'll list out all those grammar that are there in already in your GNF structure. See here, all these places you have a variable tends to a single terminal symbols, which are all allowed in CNF and which are all allowed in GNF also. Okay, norm tends to book, flight and all, and BP tends to book, read, include. So all these elements are already there in your GNF structure. Only things are S tends to NP, BP is not there. S tends to AUX, X1 is not there in your general format. S tends to verb, NP is not in the general format. These are all there in the general format. Okay, and NP tends to DET, norm is not in general format, and norm tends to noun, norm, and VP tends to verb, NP, and X1 tends to NP-VP. Okay, so I'll just show a few elements alone. See here, when you consider this production, S tends to AUX X1, it is of the structure 2 variable. But the input actually should start with the terminal symbol. So you have to check for a substitution for this AUX. We are not bothered about what comes that next. Okay, so for AUX, we have only one production, that is AUX tends to does. So when you make the substitution, this production will look like S tends to does X1. So this alpha this is a terminal symbol followed by a variable which is allowed in your general format. Okay, so this is what we are going to do. We are going to make a substitution for it. Okay, see here, S tends to verb NP. And for verb, you have the production as either book or include or read or book or include or read. You have to write all possible substitution. So S tends to, instead of verb, first make the substitution as book. Book followed by NP, or include followed by NP, or read followed by NP. So it all starts with a terminal symbol followed by a variable. It doesn't matter. And here you have NP tends to, the initial element is DET. DET is a variable which is not allowed. Instead of DET, make the substitution for this. Okay, so you have 1, 2, 3, 4 possible substitution for DET. Do all. So first you have to make the substitution as that followed by norm, or this followed by norm, or a followed by norm, or the followed by norm. Okay, just make the substitution. So you can, I think you can complete the remaining portion of it. Right now, like for this is like I have completed it, right? See, I'll just do it here. A followed by norm, and the followed by norm. Okay, so this is for your NP structure. So now when I want to make this S tends to, you have two variables, right? S tends to NP, VP, both are variables. Now instead of this NP, make this as a substitution. For NP, we can make the substitution as that norm, this norm, and norm, or the norm. So first possibility is that norm followed by VP. So that is a terminal symbol followed by two variables which is allowed, or this norm VP. So this norm followed by VP, two variables, one terminal which is allowed, and norm followed by VP. So we are just making a substitution here. See what happened when you are deriving a parse tree. You will have this S tends to NP VP. Now instead of this NP, we can have the substitution as DET and norm. Okay, for DET, we have a lot of possible substitution, right? We have this, that, this, and the. So when you make all the substitution, you have different production. That norm VP, that norm VP, or this norm VP, or and norm VP, or the norm VP. You have to write all possibilities. Okay, similarly complete for this also. This is how we have to proceed on a GNF conversion. For any grammar to be converted to a GNF, the grammar should be in CNF. And when you have a complicated grammar like this, just try to minimize your effort. Don't go for rewriting all the variables and finding your generalized structure. Okay, it will take up plenty of time for completion. Always try to find a simplified steps. Okay, thank you, dear.